Here in this problem, we are finding the concentration, highest concentration of the drug that is reached in a patient's bloodstream. So let me read the problem. And we need a graphing calculator for this. So a drug is administered to a patient and the concentration of the drug in the bloodstream is monitored at time t greater than 0 or equal to 0. So that's telling me if I'm looking at the graph, I don't have to worry about my negative side. So this t is my x-axis, which is the time. And what I have to look for is anything above 0 in hours, since the drug was given, and the y-axis will give me the concentration, C. So the concentration is my y value and my t is my x value, so time, okay, is given by this function 5t over t squared plus 1. Since I'm using my calculator, I am going to input this as 5x over x squared plus 1. And from the calculator, I'm going to see what the graph is. And I'm assuming since it's asking for highest concentration, there should be a maximum point on the graph. And I will have to look for what the maximum y value is. Maximum y value from the graph. Okay, so first let me graph this. So I inputted it here, 5 times x in parentheses divided by x squared plus 1. Now in the window, I am automatically changing my x minimum to 0, and I will keep my y minimum zeros too. We are not talking about negative concentration. And so x maximum, we can pick some number. I kept it 50, and y maximum, I have it as 5. I can keep it 10 too. So let me, keep it 40. Okay. So I'm going to hit graph. Okay, so I see the graph of the function is reaching a maximum and then kind of going like this. Okay, so this is my maximum point. So if I can use my calculator to find the maximum, and whatever the maximum y value is going to be my answer for A. So I'm going to use second calc, maximum left bound. So bring the cursor to the left side of the point. Keep moving. Okay, that's better. To the right of the point. That's better. Enter. Oops. We didn't do that right. 6 second, quit. Go back to graph again. Go repeat it. Second calc. Maximum. Left bound, enter. Enter. Enter again. That's the maximum point. So it's asking for what the maximum value is. So technically the max here, I'm seeing the coordinate as 1.00 comma 2.5. So here I just need the y coordinate, which means the answer for the first one would be 2.5 milligram per liter. So that is the highest concentration of the drug that can reach in the patient's bloodstream. Okay. So now with this information, I need to answer the next part of the question. So when I see here, looks like what happens to the drug concentration after a longer period of time. So we see that the graph is, the concentration is reaching a maximum, and then you see the graph is going down, and it's keep going closer and closer to the x-axis, which means the concentration is getting 0. So as time goes by, there will be a point where there is no drug in the blood. So the answer for this would be A. The concentration of the drug in the bloodstream goes to 0 milligram per liter as time passes on. Okay. Okay, so the next question C is asking how long does it take for the concentration to drop below 0.3 milligram per liter? So one option of doing this problem, I will have to take 0.3 and then set up my equation to 5t over t squared plus 1 and then solve this equation. So this is one option to do. Okay, so if I solve it, I will go like 0.3 times t squared plus 1 is equal to 5t. Now if I distribute this, 0.3 t squared plus 0.3 is equal to 5t, then I go 0.3 t squared minus 5t plus 0.3 equal to 0. It's a quadratic equation, so I have to factor, use quadratic formula, completing the square. This is the long way of doing it, but since I have the graphing calculator, I can use this to graph and take the value directly from here, and I think that's easier because it's recommended in this problem, right? So what I would do to do that, I'm going to graph y2. So since y1 is y1 I already have this 5x over x squared plus 1, right? So I'm going to put y2 equals 0.3. So this is going to be a horizontal line. So 0.3 is will be somewhere here. So what I'm going to look for is a horizontal line passing like this. And what I'm looking for, this point of intersection. And in this case, I'm looking at what the x value is of the point of intersection. That's what I'm looking for. So let me go y is equal to 0.3 or 0.3, and then I hit graph. Yes, my graph is intersecting. So go second calc. Now use intersect. Now it's on the first curve close to the point that I want. Yes, right? Yeah. And then enter. Second curve, jump to the second curve, enter again. And that's where the point of intersection is. So how long is it taking? The x value is 16.606449. So this value is actually x is equal to 16.606449. So if I round it off to 2 decimal places, I would say 16.61 hours.